basically we're going to look at log equations and exponential equations, but we're going to start with log equations. And really this follows, what we've been talking about in terms of these expressions and equations already. So really this will just be an extension of what we've already done. So let's start with a basic strategy. So basically with these log equations, you're going to encounter two different situations. You're either going to encounter a situation where you can rewrite this as log equals log. So strategy one would be, can I rewrite this so that, I have some kind of log expression equaling another log expression, in which case then I can just say, oh, the argument equals the other argument. So that's one strategy. The other strategy is, can I make it so that I have, log of, whatever base is equal to, some number. In which case, then you can just rewrite it as an exponential expression, right? 2 to the 3 equals x, so x equals 8. So really, when you're given any log equation, those are the two things that you want to ask yourself. Can I rewrite this as a log equals log or log equals a number? And if I can do that, then, I'm golden. So some examples of equations that you'll be asked to solve. So let's say we have something pretty basic like log base 2 of x plus 12 is equal to 3. Then we would have, okay, I've got log equals number. So rewrite this as an exponential expression. I have 2 to the third power equals x plus 12. So 8 equals x plus 12. So x is equal to 8 minus 12, which is negative 4. So, all right, now remember, domain of a log equation is restricted, right? You can't take log of a negative number, so you have to check your solutions with these. So to check your solution, you have to go back to the original, which is log base 2 of x plus 12 equals 3, and we'll sub in x equals negative 4. So log base 2 of negative 4 plus 12 equals 3. So we have log base 2 of 8 equals 3. We know that 2 cubed equals 8. So it checks, and I'm good. So make sure you check these because occasionally, you'll get an extraneous solution, like with the rational equations and things like that. So this one is good. We have one solution, and it is negative 4. All right, so let's try another one. All right, let's try log base 2 of x plus 4 is equal to 2 plus log base 2 of x plus 7. Okay, so again, the question that I'm asking myself is, do I have log equals log or log equals number? And sometimes you have to do a little bit of algebraic manipulation to get yourself there. So really, if I'm looking at this, the log expression is one term. On the right of the equal side, the 2 is one term, and the other log expression is a term. So if a number is one of the terms in the equation, then the option that I want to go for is, log equals number, and change it to an exponential expression. So I want to get the two log expressions on one side. So I'll have log base 2 of x plus 4 minus log base 2 of x plus 7 is equal to 2. Now I want to use properties of logs to rewrite the left side of the equation as a single log. So this is log base 2. I'm subtracting. So this would be of x plus 4 over x plus 7 equals 2. So now I have log equals number. So I'm just going to rewrite this as an exponential expression. So this is 2 to the second power equals x plus 4 over x plus 7. So now I have a rational equation to solve. So this will be, what is that? 2 squared is 4 is equal to x plus 4 over x plus 7. So multiply both sides by x plus 7. So this is 4x plus 28 is equal to, they cancel on this side, so x plus 4. So subtract x. This is 3x. Subtract 28. That would be is equal to, what, negative 24. So x is equal to negative 8. Okay, good deal. So now let's go ahead and check this. All right, so we have to go back to the original equation. So let's jot that down. We have log base 2 of x plus 4 is equal to 2 plus log base 2 of x plus 7. Okay, so subbing in x equals negative 8. Log base 2 of negative 8 plus 4 is negative 4. Okay, so really we fail right there. You can't take the log of a negative number, so that means that this doesn't work. So we would say there is no solution. Okay. All right, so let's try one more. Okay, so last example for these. Let's take a look at log base 8 of 6 plus log base 8 of x minus 2 is equal to log base 8 of x. So again, what you want to ask yourself is log equals log or log equals number. Since every single term has a log, then I want to go with a log equals log. So I'm going to combine the left using properties of logs. So this would be 6 times x minus 2 is equal to log base 8 of x. So now, since I have two logs of the same base equal to each other, I can just set the arguments of the logs equal to each other. So I can say 6 times x minus 2 is equal to x. So 6x minus 12 is equal to x. We'll subtract x, so that would be 5x. Take the 12 to the other side. So x is equal to 12 over 5. Okay, good deal. So let's plug her in and see what we get. Okay, so let's see, find some space. All right, so plugging into the original. So we have log base 8 of 6 plus log base 8 of, that's 12 over 5 minus 2 is equal to log of 8 of 12 over 5. Okay, so this will be log base 8 of 6 times, so I'm going to just do a little arithmetic here. If we have 12 over 5, let's rewrite 2 as a denominator of 5. So that would be 2 over 5. And then we would have equals log base 8 of 12 over 5. And lo and behold, here is our 2 log base 8s. 6 times 2 is 12, so this would be 12 over 5 is equal to 12 over 5. So there you go. All right, so like I said, with each of these, and you'll see the different topics in ALEKS, it's really just, can I rewrite this as a log equals log or log equals number? If it's log equals log, then you can set the two arguments equal to each other. If it's log equals number, you just change it to an exponential expression and solve. But what you do want to be careful of is that you do want to check your solutions with these, because as we saw, it's possible, to get no solution. All right, so I'm going to stop this one here, and I'll do another one with the exponential equations.